Okay, now we are in the final part of sample preparation. Okay, sample preparation. Okay, located at the fifth step in a chemical analysis. So this is the final part of sample preparation, i.e., it is for gas. Okay, how do we want to prepare the gas for sample analysis? Okay. Okay. Chemical analysis on gas is very much depending on how you sample the gas. Okay. So imagine that you do sampling on gas. Later we'll do and see the next slide. Okay. After you sample the gas, okay, you preserve and store. Okay. Store in airtight container or in gas we call as tight bag. Okay. Since gas is already homogeneous, most of gas is already homogeneous, not so much preparation that we need to use. Okay. Usually we need the apparatus that is connected to the instrument, like what we saw in the headspace solid phase microextraction just now. Headspace SPME. For organic analytes, okay, you have two options, i.e., the headspace that I showed you, and another one is the conventional method, what we call as purge and trap. This literal meaning of purge is meaning that you are purging your gas into a column and then you trap it inside adsorbent. Okay, sounds very much like SPE, right? So it's the same case over here. And then you do chromatography analysis, GC, for example. Okay, can we do HPLC? No, we cannot do HPLC. We can only do GC. Okay, let's go back to how we sample the gas. Sampling, okay, gas analysis is not really inside the inside the weekly schedule. It's not really inside the subject, okay, as the topic. But for forensic chemistry student, you guys maybe one day will need to analyze breath sample. Okay. So when you do blood alcohol, alcohol in breath analyzer and so on, so you understand how gas should be sampled. Okay, gas, because it is tend to be homogeneous, okay, it is easily occupying a space. Okay, therefore a large volume of gas sample is required to make this happen. Okay, how do we sample gas? Specific to forensic analysis, forensic chemistry, we look into the last method, i.e., we can sample the breath sample inside sampling bag. Ini. Okay, so you take the blow sample and then you can go and transfer it into GC septa vial. Okay. And then, if you are working in environmental air analysis, you have the high volume sampler, which contain filter to collect particulates. Other than particulates, you are also like collecting gas. And then you can also use gas sampling bulk glass from burning activity, just like this one. Okay, this one is a gas sampling bulk glass used in taking H2S gas. H2S gas, which is a very pungent gas, to analyze it. Okay, after you sample, what should you do? Okay, you put inside the specific container, maybe a glass vial with septa. Glass vial with septa. Septa is like a cap containing a rubber ring, not rubber ring, is like a rubber face over here, whereby when syringe goes in, needle syringe goes in, and then when it goes out again, it will not leave any big hole. Okay, means that it is like tightening up the vial. After that, you can go into GC. Okay, if gas is your sample. But what if you are generating gas from solution? Okay, like in SPME just now, we can make this solution to be vaporizing, and when it is vaporizing, you see the gas goes out, okay, containing the volatilized analyte. Okay, it goes up and then it goes into the trap. So the trap over here contain adsorbent that can adsorb on it, and then when you ask those gas to be purged inside GC, it is dissolving. Okay, let us see the video on purge and trap.
Apa tu?
Mirror is working. What's that? That's the push and trap.
Wow. Apa tu?
This is work.
Apa tu?
So you can see that this is the EPA method for analyzing volatile organic carbon using GC and push and trap. Push and trap is a conventional method that is used largely before from 20 or 30 years ago, and it is already inside the standard method. Okay, so if you are working in routine monitoring in Department of Chemistry, you can see push and trap connected to GC a lot. Okay. Okay, this is what I said just now about having headspace like apparatus connected to GC. So this is suitable for directly gas sample, or you can also analyze a liquid sample that is having low boiling point. Means that it is easily vaporizing. So you can collect the gas immediately inside the GC. Okay, so if let's say you have a brief sample inside the bag, you can transfer inside the SEPTA vial, and then you put the SEPTA vial over here and then analyze with GC. Okay, as simple as that. So we finish on the sampling and sample preparation for gas, and now we go into a small, very small subtopic on how do we want to sample prepare gunshot residue. Okay, gunshot residue, or abbreviated as GSR, is the residue deposited on the hands or clothes of the perpetrator who discharged a firearm. Okay, it actually composed of burnt and unburnt particles from the explosive primer and the propellant. And most of the materials are inorganic material. So this category is solid sample, okay, containing inorganic analytes. Okay, if you are going to analyze with instruments such as spectroscopy, you know immediately you are going to do digestion, right? Okay, either it's wet digestion or microwave digestion. But what if you want to analyze the components of inorganic analytes using an instrument that can characterize the inorganic analytes while it is in solid? Okay, that's where we have what we call as the scanning electron microscopy. Okay, scanning electron microscopy, and it can also attach to EDX. EDX is electron dispersive X-ray. Okay, and the spectrum you will get is something like this. Okay, you can get lead, antimony, and barium, which are the components for GSR. So it means that this method is straightforward, whereby you don't have to convert your solid sample into solution if you don't have the apparatus. Okay, this is important for you to understand because it is already accepted as ASTM method. Therefore, there is a necessity for me to make you aware of this method. Okay, so how to collect and sample prep for GSR? So over here we have like a stub, what we call as stub. Dia macam subang, okay, macam ni, like a stub over here. We put all those particles on top of this. This is really small. It's like 10 cent size. Okay, on this stub you will put your GSR, but in order for the GSR to be able to be detected by this SEM, which is electron microscopy, you have to coat all these particles with precious metal. For example, gold, or we can use platinum. All those precious gold, okay, is okay.
You can watch my iPad.
Yes, I have my iPad. Okay, it can enable the electron transfer between the inorganic analytes to the microscope. So how do we sample prep? You just take the stub, okay, rub on palm or at the wrist over here. Can also do on clothing. Okay, and then put inside the sputtering chamber, whereby you can sputter or coat with gold or platinum. Okay, so you can imagine that one sample analysis is expensive. Okay, one sample analysis can give you the inorganic elements as well as the photograph. Okay, that's the best thing about this. You can get photograph. And in UTM, one sample is, I think, around 150 ringgit or 300 ringgit per sample because of the coating. Okay, so you will get something like a chromatogram, but this is not chromatogram. It is actually called spectrum. Why is it called spectrum? Because this is a spectroscopy method. Therefore, we call it as spectrum. Okay, so you will get spectrum like this. Okay, you can see that there's more lead as compared to antimony and barium. If you have all those three elements, this can classify the potential this can classify the evidence as the GSR. Okay, it is given out in terms of percentage. Okay, so I will stop the video here and we will continue with calibration curve.